We got
4
it.
points.
Here we go.
Oh.
So what's your goal for like 4 points? Like you know how you said 10 points, you want like 6 to 7 points, like
He wants all 4
Oh.
all points, or like.
I feel like if you can grab at least half, you're doing great.
Alright.
Okay.
He wants 5.
And there'll be some, maybe you'll get all 4, some you don't get any because you just got like, the question could be just got you down. Just like it's written in a way that you just need the time to get to. It's like, you know, but I feel like there's always in these, there's something you can grab. And I know like the final there was that spectrophotometry
That one
question
question.
that got people crazy, but if you looked at it another way, it's like, oh, I probably should have got at least 2 out of the 4. But you know, at this point, just see what you can grab here. The big money makers in terms of where you're going to make your mark in terms of grade on this, multiple choice, 1 through 3. These, of course, there's a bunch of these questions here, and there's points to be earned here, but certainly you want to do the best that you can. But yeah, if you can get, in my opinion, if you can grab half, at least half, or you know, that's a good thing. So we have calcium carbonate breaking down to calcium oxide, and then CO2 gas, another gas. Okay. When heated, calcium carbonate decomposes according to the equation above. In a study of the decomposition, student added 50 gram sample of powdered calcium carbonate to 1 liter rigid container that was probably previously evacuated. Okay. The student sealed the container, pumped out all the gases. Here we go. Then heated the container to an oven to 1100 K. As the container was heated, the total pressure of CO2 was measured over time. The data are plotted in the graph below. Okay, so we can clearly see that as we heated, as the temperature rose, okay, it decomposed into a gas. That gas created an increase in pressure, and you can see that it leveled off. Okay, that's a key to this, I think. Student repeated the experiment, but this time the student used a 100 gram sample of powdered calcium carbonate. In the experiment, the final pressure container was 1.04 atmospheres. Okay, so did they give us a final pressure? So
Same final pressure.
yeah, okay. So is this what this was? So the container was 1.04, which looks like what this is right here. Okay, which was the same final pressure as the first experiment. Okay, so if you notice, it had nothing to do with the what? How much of the solid, correct? Think about that for a second as we look at the questions. Calculate the number of moles of CO2 present in the container after 20 minutes of heating. Okay, so after 20 minutes of heating, okay, we have 1.04 atm, that's our pressure, okay, and they want the moles of CO2. Now, we haven't seen this enough, but the gas law problems will sneak up on you, okay? What do we have? We have a volume, a 1 liter container, right? What else do we have? We have a pressure, okay? So we've got a pressure. We have a temperature. Couldn't we solve for moles? So this is nothing more than a gas law problem, which is good to review. Keep in your mind, because you could be racking yourself, how do I get the moles from the pressure, and how do I do that? All this is, that's why it's just good review, PV equals nRT. Solve for moles, PV over RT is equal to N. Now, if you remember the R constant, you have a couple of them, you're going to use the one that's atmospheres liters. So I think it's 0.0821 atmosphere liters, that's your R from your reference table. Temperature has to be in Kelvin. We know that's 1100. Not sure why I'm writing this off to the side, but okay. And then of course I have my pressure, which is already in atmospheres, 1.04, I think at 20 atm. And then my volume is 1 liter, right? Is it a 1 liter container? Yes. So clearly all this is a quick PV. So 1.04 divided by 0.0821 times 1100. And this is a really good review problem because we haven't done too much gas laws. There really isn't a lot, but here's one that pops up. Okay, so if I did this correctly, and I think I did, okay, my N is equal to 0.0115. And that's my moles, and that's my first point, I would think. B, there's 4 questions, 4 points. The student claimed that the final pressure in the container in each experiment became constant because all of the calcium carbonate had decomposed. Based on the data in the experiments, do you agree with this claim? This claim. They said, so that B is asking you to evaluate the scenario here. Because both tests, one with a little bit of calcium carbonate, one with a lot, they both had the same pressure after 20 minutes. The student claimed that the final pressure in the container of each became constant because all of the calcium carbonate decomposed. Do you agree with that? I disagree with that because if it was a completion reaction, wouldn't there be a heck of a lot more CO2 produced if it went forward? The key is, the reason why there was leveling off is because they reached what? Equilibrium. Right. So the student claimed that the final pressure in the container in each experiment became constant because all of the CO2, based on the claim, I disagree. And you just can't say disagree. I disagree because both experiments had the same pressure, meaning they both reached equilibrium. And not all of the calcium carbonate. Or you could say if all the calcium carbonate reacted in a completion reaction, there would be different pressures. Because the pressures are the same, they both achieve the same equilibrium, meaning the same amount of what? Calcium carbonate reacted. Letter C. After 20 minutes, some CO2 was injected into the container, initially raising the pressure to 1.5. Would the final pressure inside the container be less than, greater than, or equal to 1.04? Explain your reasoning. Okay. Now, if we injected more CO2, we know that this has a Kp, some number, who cares what it is. We increase the CO2. Again, Le Chatelier's principle, stress response. If I increase CO2, the reaction is going to look to what? Decrease CO2 to get back to equilibrium. So the question isn't about the initial, it's about after some time period, right? So it says, would the final pressure inside the container be less than, greater than, or equal to 1.04? Okay? And what would you guys say there? How will it lower the CO2 that you added? How would it lower it? What would a reaction do? It would drive the reverse reaction, correct. What is Kp equal to? Products over reactants. Who doesn't apply? Right. So the Kp is based upon what? Right. So because there's no other chemicals involved in this case, it would go back to the same number. Right? Usually it never does that because it would change the other values. But because there's nothing else in the Kp, in this case, and that's a tough little one to recognize. I can see going fast and skipping that. But in this case, because the Kp is based upon just the CO2, it's the only one that's a gas or an aqueous, then it would reset back to the same CO2. You'd make more calcium carbonate appear, but it would keep going until what? Kp equals CO2 again. Okay, very important. You saw that. All right? And then D, are there sufficient data obtained in the experiments to determine the value of the equilibrium constants Kp? And of course, based on what we just said, you would say what? Yes, because the Kp just depends upon the concentration of the CO2. Or, again, if it's Kp, I probably should write what? Parentheses, the partial pressure. Although I could write in this case C, moles over liters. All right, so that, I think that was a great one to end up on because that went over a couple of things. Number one, gas law problem. Like, how do I do this? Oh yeah, gas law, yes.
Would it be wrong if you put the brackets by accident?
No, because I wrote Kp.
Oh.
Okay, so they weren't asking you to do
What
that.
if they are asking it in some?
If they ask you for the equilibrium expression and you have gases in your reaction, and they're not doing molarities, doing partial pressures, you're supposed to put parentheses. I believe you will not get the full point for that. I know that's really stickler. I've seen that in the past. All right. Certainly, if you run into something this weekend, and you say, could you explain this to me? I don't get this here. I'll do that. If you have uncovered every single multiple choice in these 3 exams, okay, and looked at and completed the part 2s, hopefully you're seeing a lot of the parallels, right? You're going to see something different. They're going to write new questions, but they're going to be like these questions again. The same stuff is going to appear. So when you see something that looks like it's so foreign and never seen it before, you've got to convince yourself, okay, let me just unravel this. This is something I've seen before. If you've uncorked and done your due diligence and reviewed these 2 practice exams, especially the multiple choice of me, there's nothing they can show you haven't seen before in terms of what the answers would be like. They're going to present it differently. That's their job. And you say, okay, what are they getting after here? Oh, pressure. I got temperature, volume. I'm going to solve for moles here. And if you don't get it, if you didn't see one of these, do not let it get you down. Taking this test under stress, you're going to get stuff wrong. But don't let something that you couldn't figure out mess up the 5 questions that what? You do know. See the entire test. Make sure you see me Monday morning. I want to see you. I'll have some food for you.
Do I have to
Okay.
go for a theory? Or do I rather not?
No, I don't think we have.